Hello, welcome to my channel, Nightlight Science Stories. Today, we are embarking on a journey to the single most isolated place on our planet. Imagine standing on the edge of a precipice that plunges down further than Mount Everest stands tall. This is the Mariana Trench, a scar on the Earth's crust that hides secrets older than history itself. As we leave the sunlit surface behind, prepare your mind for a descent into absolute darkness. The journey begins in the Twilight Zone, where life is vibrant and familiar. But as we descend past 200 meters, the light begins to fade rapidly, turning from a bright turquoise to a deep, ominous indigo. The temperature drops and the water pressure starts to build against our vessel. We are leaving the world of humans and entering a realm that belongs to the deep. The ocean here is vast, silent, and incredibly patient, waiting to reveal its mysteries. We have now reached the Twilight Zone, a depth where sunlight is nothing more than a distant memory. Here, at 1,000 meters deep, the creatures have evolved to create their own light. You can see faint flashes of bioluminescence in the distance, like ghostly fireflies in a dense forest. This is nature's way of communicating in the eternal gloom. The pressure here is already crushing, enough to implode a standard submarine, yet life finds a way to thrive. In this twilight realm, predators lurk in the shadows, using their glowing lures to attract unsuspecting prey. The water is cold, hovering just above freezing, preserving the ancient stillness of the ocean. It feels like we are traveling through outer space, surrounded by alien life forms that have never seen the sun. Every meter we descend brings us closer to the unknown, increasing the sense of isolation and wonder in this vast underwater universe. Welcome to the Midnight Zone, 4,000 meters down. Here, the darkness is absolute and oppressive. There is no day or night, only an endless pitch-black void. The creatures here are the stuff of nightmares and legends. Look closely at the anglerfish, a master of deception with its glowing lure dangling in front of razor-sharp teeth. In this nutrient-poor environment, every meal is a rare event, so evolution has favored the monstrous and the efficient. The pressure is now immense, equal to an elephant standing on your thumb. It is a world of crushing weight where skeletons would collapse, so animals here often have gelatinous bodies or no air spaces at all. They drift silently, conserving every ounce of energy in the freezing dark. It is a hauntingly beautiful ecosystem, governed by the harsh laws of physics and survival. We are truly intruders in a world that was never meant for human eyes. We descend further into the abyss, the abyssal zone, stretching down to 6,000 meters. This vast plain covers much of the ocean floor, a silent desert of fine sediment and strange ancient rock formations. The water is near freezing and the silence is deafening. Yet, even here, life persists. Sea cucumbers and brittle stars scour the floor for marine snow, organic debris falling from the surface miles above. It is a slow, timeless existence. This zone is the largest ecosystem on Earth, yet it remains less explored than the surface of Mars. The creatures here move in slow motion, living for decades or even centuries. The isolation is total. There is a mystical quality to the abyss, a sense of ancient preservation. The darkness here is not empty. It is full of potential and history, holding chemical secrets that might explain the origins of life on our planet billions of years ago. We are now crossing the threshold into the Hadal Zone, named after Hades, the underworld god. We are entering the trench itself, a V-shaped canyon formed by the collision of massive tectonic plates. The Pacific Plate is diving beneath the Mariana Plate, creating this colossal chasm. The walls rise around us like the mountains of a drowned world, jagged and formidable. The sense of scale here is humbling. We are tiny specks in a geological giant. At depths beyond 6,000 meters, the conditions are extreme. The pressure is over 1,000 times greater than at sea level. It is a violent, geologically active place where earthquakes are born in the deep. Yet, the water is strangely clear. Without sunlight to fuel algae, the visibility is surprisingly good if you have a light source. We are descending into the Earth's basement, a place where the planet recycles its own crust in a slow, grinding dance. Finally, we approach the bottom, Challenger Deep. We are now approximately 10,935 meters below the surface. If you dropped Mount Everest here, its peak would still be over 2 kilometers underwater. This is the ultimate frontier. The landscape is alien, a flat beige floor consisting of biogenic ooze, the remains of microscopic life that has settled here over millions of years. It looks like the surface of the moon, untouched and desolate. The isolation here is palpable. Only a handful of human beings have ever visited this spot, fewer than have walked on the moon. The pressure is 8 tons per square inch. It is hard to comprehend, but life exists even here. We see simpler forms, distinct from the monsters above. They are the survivors of the ultimate extreme, thriving where we thought nothing could exist. This is the true bottom of the world, silent and profound. What lives at this crushing depth? Meet the Xenophyophores, giant single-celled organisms that resemble delicate sponges. They are fragile giants of the microbial world, highly adapted to the heavy metals and intense pressure of the trench. Alongside them, we find amphipods, shrimp-like scavengers that grow to unusual sizes, a phenomenon known as deep-sea gigantism. They scuttle across the sediment, cleaning up whatever organic matter drifts down. These creatures have specialized proteins to prevent their cells from collapsing under the pressure. Their existence challenges our understanding of biology. They do not rely on sunlight, but on the chemical energy of the deep and the falling debris from above. It is a slow-motion ecosystem, isolated from the chaotic changes of the surface world. Observing them feels like looking back in time to a primordial era of Earth's history. You might think the bottom of the trench is silent, but it is surprisingly noisy. Hydrophones placed here have captured the rumble of earthquakes, the distant moans of baleen whales miles above, and the grinding of tectonic plates. The trench acts as an acoustic chamber, trapping and amplifying sounds from across the ocean. It is a haunting symphony of the planet's geological heartbeat, a constant reminder that the Earth is alive and moving. This acoustic environment is crucial for the few animals that navigate these depths. Sound travels faster and further in water than in air, connecting this isolated trench to the rest of the ocean. Listening to these recordings is eerie. You hear the raw power of the planet. It is a sensory experience that combines the terror of the deep with the scientific wonder of how interconnected our planet systems truly are, even at 11 kilometers down. The history of exploring this place is a testament to human curiosity. In 1960, Don Walsh and Jacques Picard were the first to descend in the bathyscaphe Trieste. They heard a loud crack on the way down, a window pane cracking, but continued anyway. Decades later, film director James Cameron made a solo dive, describing the bottom as desolate and lunar. Most recently, Victor Vesovo has mapped the trench in high resolution. Each expedition brings back new samples and new questions. We have discovered new species of snailfish that are translucent and fragile, melting rapidly if brought to the surface. These missions are dangerous and expensive, pushing the limits of engineering. Just like space exploration, exploring the deep ocean requires technology that can withstand environments hostile to human life. It is the ultimate test of our drive to discover the unknown. But perhaps the most shocking discovery at the bottom of the Mariana Trench was not a monster, but a mirror. In the deepest place on Earth, explorers found a plastic bag and candy wrappers. Even here, 11 kilometers down, human impact is visible. Microplastics have been found in the stomachs of the amphipods living in Challenger Deep. It is a heartbreaking realization that no part of our planet is immune to our influence. This discovery changes the narrative of the trench from a distant alien world to a fragile part of our own ecosystem. The chemicals and pollutants we release eventually find their way to the deepest dark. It serves as a stark warning. The Mariana Trench is not just a geological curiosity, it is a final sink for the planet's health. Understanding it helps us understand the global reach of our actions, connecting our daily lives to the abyss. Rising slightly from the deepest pits, we encounter one of the most alien landscapes on Earth, hydrothermal vents, often called black smokers. These are underwater geysers spewing superheated water rich in minerals from the Earth's crust. The water here can reach 400 degrees Celsius, yet it doesn't boil because of the crushing pressure. It is a violent, toxic environment that mimics the conditions of the early Earth, potentially showing us how life first began. Surrounding these deadly vents is an explosion of life. Giant tube worms, some over 2 meters long, thrive here without a mouth or stomach. They rely entirely on symbiotic bacteria living inside them to convert the toxic chemicals into energy, a process called chemosynthesis. This proves that life does not always need the sun. It is a biological miracle occurring in the darkest depths, suggesting that life could exist on icy moons like Europa or Enceladus. But these mineral-rich environments have attracted more than just scientists. The bottom of the ocean is scattered with polymetallic nodules, potato-sized rocks, containing valuable metals like manganese, nickel, and cobalt. These are essential for our batteries and smartphones. This has sparked a controversial deep-sea gold rush. Nations and corporations are eyeing the ocean floor as the next frontier for mining, planning to send massive machines to harvest these resources. The potential consequences are alarming. Deep-sea mining could destroy these fragile, slow-growing ecosystems before we even fully understand them. The sediment plumes created by mining could choke filter feeders miles away. It is a classic conflict between human progress and environmental preservation. We are standing at a crossroads, deciding whether to protect this final frontier or exploit it for its raw materials, potentially causing irreversible damage to the ocean's heart. Rising up from the floor to the mid-waters, we find the realm of giants. This is the hunting ground of the colossal squid, a creature with eyes the size of dinner plates, the largest eyes in the animal kingdom. They are designed to spot the faint silhouette of their only predator, the sperm whale. Evidence of their titanic battles has been found on the scarred skin of whales, telling stories of life and death struggles in the crushing dark. The colossal squid is a true monster of the deep, growing up to 14 meters long. It possesses rotating hooks on its tentacles, not just suckers. For centuries, these creatures were myths, the kraken of sailor lore. Today, we know they are real, but they remain elusive. We have very little footage of them alive. They remind us that the ocean still hides apex predators that are as large as a school bus, patrolling depths we can barely reach. Another resident of the deep is the vampire squid, Vampiroteuthis infernalis, which literally translates to vampire squid from hell. Despite the terrifying name, it is a gentle scavenger. It lives in the oxygen minimum zone, where few other predators can survive. When threatened, it doesn't shoot ink. Instead, it inverts its cape of spines and exposes glowing blue eyes to confuse attackers. It is a master of survival in a suffocating environment. This creature is a living fossil, unchanged for millions of years. It feeds on marine snow, the drifting particles of dead organic matter. The vampire squid drifts through the water like a dark red phantom, conserving energy in the low oxygen depths. Its existence shows how evolution can craft specialized solutions for the most extreme conditions. In the deep ocean, being slow and efficient is often better than being fast and aggressive. Perhaps the strangest face in the deep belongs to the barrelli fish. Its head is completely transparent, filled with fluid. Those green orbs you see inside its head are actually its eyes, which can rotate to look upward, spotting the silhouettes of prey against the faint surface light. The two spots above its mouth that look like eyes are actually olfactory organs for smell. It is a biological design that looks like science fiction. This transparency allows the barrelli to see without being seen, stealing food from stinging jellyfish tentacles. It highlights the bizarre evolutionary pressures of the deep. In a world where light is scarce and danger is everywhere, animals have developed X-ray vision, invisibility, and deceptive lures. Every creature we find here breaks the rules of what we thought was possible in nature, expanding our definition of life itself. The ocean floor also hides geographical wonders that defy logic, like underwater lakes and waterfalls. In the Denmark Strait, cold, dense water sinks below warmer water, creating the world's largest waterfall underwater. It drops 3,500 meters, 3 times the height of Angel Falls. Though we can't see it crashing like a surface waterfall, the volume of water moving is massive, driving the global ocean currents that regulate our climate. These deep water currents are the engine of the planet's climate system, known as the global conveyor belt. They transport heat from the equator to the poles and nutrients from the deep to the surface. If these currents were to stop or slow down due to climate change, the consequences for life on land would be catastrophic. The deep ocean is not disconnected from us. It is the thermostat and the circulatory system of our entire world. The deep ocean is also the world's largest museum. Shipwrecks like the Titanic rest in the dark, preserved by the lack of sunlight and low oxygen. Metal-eating bacteria are slowly consuming the Titanic, creating rusticles that look like icicles. These wrecks are time capsules, freezing moments of tragedy in history. They become artificial reefs, providing a home for deep-sea life amidst the remnants of human engineering. Exploring these wrecks requires respect. They are grave sites and archaeological treasures, but they also teach us about how the ocean reclaims everything eventually. The pressure, the salt, and the bacteria work together to break down even the strongest steel. In a few decades, the Titanic might be nothing more than a rust stain on the ocean floor. It is a poignant reminder of nature's power over man's greatest creations. Unlike tropical reefs, deep-sea coral reefs grow in the cold, dark, without sunlight. These corals are stark white or pale pink, relying on drifting food particles rather than photosynthesis. They grow incredibly slowly. Some colonies are thousands of years old, making them the oldest living animals on Earth. They form complex forests that provide shelter for fish and crabs in the open abyssal plains. These fragile gardens are easily destroyed by bottom trawling fishing nets. Because they grow so slowly, damage to a deep-sea reef is effectively permanent on human timescales. Scientists are racing to map these areas to protect them. They are biodiversity hotspots in the deep, proven that even in the cold and dark, life creates complex, interconnected communities. They are hidden oases that we are only just beginning to understand. The ocean is also a place of unsolved mysteries. In 1997, hydrophones captured an ultra-low frequency sound known as the blue. It was powerful enough to be heard across the entire Pacific. For years, people speculated it was a giant unknown beast, while scientists later concluded it was likely an icequake from cracking glaciers. The initial fear it sparked reveals our deep-seated primal fear of what might be hiding in the 95% of the ocean we haven't explored. We know more about the surface of Mars than our own ocean floor. New species are discovered on almost every deep dive. The bloop reminds us that the ocean is vast and largely silent to our ears, but full of events we miss. Whether it's geological shifts or unknown leviathans, the deep ocean retains its capacity to surprise and terrify us. It is the last great mystery on our home planet. Looking to the future, could humans ever live in the deep? Concepts for underwater habitats and research stations are being developed. Unlike space, the ocean provides protection from radiation, though the pressure is a deadly challenge. Living underwater could unlock new medicines from unique marine compounds and sustainable energy sources. It is a sci-fi dream that is slowly edging closer to reality as our technology improves. As we conclude this journey into the deep, remember that the ocean is the life support system of Earth. It generates half our oxygen and absorbs most of our excess heat. Protecting the Mariana Trench and the wider ocean is not just about saving weird fish. It's about saving ourselves. Thank you for diving with Nightlight Science Stories. If you enjoyed this deep descent, don't forget to like and subscribe for more journeys into the unknown. While exploring these depths, we are essentially traveling back in time. The deep ocean changes much slower than the surface, acting as a sanctuary for living fossils. The most famous of these is the coelacanth. Scientists thought this fish went extinct 65 million years ago, along with the dinosaurs. But in 1938, one was found alive off the coast of South Africa, shocking the scientific world. Finding the coelacanth was like finding a living T-Rex in your backyard. It hides in deep underwater caves, moving its fins like the legs of a land animal. This creature is a bridge between fish and the first amphibians that walked on land. Its existence in the Twilight Zone suggests that the deep ocean is a vault, preserving chapters of Earth's history that have been erased everywhere else. Crawling along the sediment, we find another relic, the giant isopod. It looks like a common garden pillbug, but it can grow to the size of a cat. This is a prime example of deep-sea gigantism. Why do they get so big? One theory is that the cold temperature slows down their metabolism, allowing them to grow larger over a much longer lifespan than their surface relatives. These scavengers can survive for years without eating. When a whale carcass falls, they gorge themselves to the point where they can't move. They are the cleanup crew of the abyss, recycling biological matter. Their alien appearance has remained virtually unchanged for 160 million years. In the stability of the deep dark, if a design works, nature sees no reason to change it. In the gloom, we might encounter the goblin shark. With its flabby pink skin and terrifying protruding jaws, it looks like a mistake of evolution, but it is perfectly adapted. Its skin is pink because red light doesn't penetrate deep water, making it effectively invisible. Its jaw works like a slingshot, shooting forward to snatch prey before they even realize a predator is near. This species is a survivor from a lineage 125 million years old. While sharks on the surface evolved to be fast hunters, the goblin shark evolved for stealth and ambush in the dark. It detects the faint electric fields of other animals using sensors in its snout. It is a drifting phantom, a reminder that the rules of engagement are different when you can't see your enemy. Another living fossil is the frilled shark, which looks more like an eel or a sea serpent than a shark. It has rows of needle-like teeth designed to hook slippery squid. Reports of sea serpents by ancient sailors might have actually been sightings of this creature coming to the surface. It swims with a serpentine motion, unlike any modern shark, mimicking the swimming style of prehistoric marine reptiles. The deep ocean has barely changed in temperature or chemistry for millions of years, providing a stable bunker against the asteroid impacts and ice ages that wiped out surface life. Creatures like the frilled shark show us what the oceans looked like in the Jurassic period. Every dive is a paleontology lesson where the fossils are still swimming and hunting. But the deep ocean isn't just about biology. It's about geology. The Mariana Trench exists because of a process called subduction. This is where the Pacific Plate, a massive slab of the Earth's crust, is crashing into the Mariana Plate. The Pacific Plate is being forced downward into the Earth's mantle. This grinding motion is what digs the trench deeper and deeper over millions of years. It is a slow-motion collision of giants. As the plate descends, it melts, recycling the rock back into the Earth's molten core. This process also traps water in the rocks and drags it down into the mantle. Scientists estimate that there might be huge oceans worth of water locked inside the rocks deep within the Earth's interior, driven there by these subduction zones. This tectonic activity makes the region part of the Ring of Fire. Parallel to the trench is a chain of underwater volcanoes. When the subducting plate melts, magma rises to form these volcanoes. Some of them grow tall enough to break the surface and form islands, while others erupt silently in the dark. The pressure is so high that the water doesn't boil, but the heat energy released is immense. These underwater eruptions create pillow lava's bulbous rock formations that cool instantly upon hitting the cold seawater. This constant geological recycling is what keeps our planet alive. Without plate tectonics, Earth would be a dead, stagnant rock like Mars. The violence of the trench is actually the heartbeat of a living planet, reshaping the continents and regulating the atmosphere over eons. How do we know the depth of these places? We use sonar sound navigation and ranging. A ship on the surface sends a sound ping down. We measure how long it takes for the echo to bounce back. Since we know the speed of sound in water, we can calculate the depth. However, the water temperature and salinity change the speed of sound, making precise measurement incredibly difficult. This is why the measured depth of the Challenger Deep has changed over the years. Early measurements with ropes and weights were inaccurate. Modern multi-beam sonar gives us a 3D map of the trench floor, revealing a rugged, complex terrain rather than a smooth bowl. Yet, we have mapped the surface of the Moon and Mars in better detail than our own ocean floor. The geological instability of the trench poses a real threat: tsunamis. When the tectonic plates stuck in the subduction zone suddenly slip, they release massive amounts of energy, displacing the water column. Because the water here is so deep, the wave moves at the speed of a jet plane, over 800 kilometers per hour. It is a silent killer that goes unnoticed in the deep until it reaches shallow water. Understanding the physics of the trench is crucial for early warning systems. Sensors placed on the ocean floor monitor pressure changes to detect these waves before they hit the coast. The trench is not just a remote curiosity. Its geological movements have direct, often devastating consequences for the millions of people living on the Pacific Rim. It is a sleeping dragon that occasionally wakes up. Despite the danger, the deep ocean performs a critical service: carbon sequestration. The marine snow we mentioned earlier, dead plankton, fecal matter, and dust drifts down continuously. This biological pump moves carbon from the atmosphere to the deep ocean, locking it away in the sediment for millions of years. The abyss is the planet's largest carbon sink. Without this process, the Earth's atmosphere would be much hotter. The creatures of the deep, by eating and burying this carbon, are silent allies in the fight against climate change. Disturbing the ocean floor through mining or trawling could release this stored carbon back into the water, potentially accelerating global warming. The health of the abyss is directly linked to the air we breathe. As we wrap up this section on history and geology, we must address the most popular myth: the megalodon. Could a prehistoric giant shark still be hiding in the Mariana Trench? Scientifically, it's highly unlikely. The megalodon favored warm, shallow coastal waters full of whales, not the freezing, high-pressure depths where food is scarce. However, the discovery of their fossilized teeth in deep waters fuels the imagination. While the megalodon is gone, the trench hides creatures just as fascinating and perhaps even more terrifying because they are real. We have only explored less than 5% of the ocean. In the next part of our journey, we'll look at the weirdest adaptations, how life turns into glass, jelly, and light to survive the impossible. Let's examine the Venus flower basket, a sponge made entirely of glass. Its skeleton is an intricate lattice of silica, woven so perfectly that it mimics modern fiber optic cables. It is stronger and more flexible than human-made glass. In Japan, these sponges are given as wedding gifts because they often house a pair of shrimp that enter as larvae and grow too large to ever escape, spending their entire lives trapped together inside this crystal prison. This glass house is not just a prison but a fortress. The intricate structure directs water flow to maximize feeding efficiency while protecting the shrimp. In return, the shrimp clean the sponge. It is a beautiful example of symbiosis in the deep. Engineers are studying these sponges to learn how to build stronger bridges and more efficient fiber optics, proving that nature is the ultimate architect even in the darkest depths. Not all monsters are scary. Some are undeniably cute. Meet the Dumbo octopus, named after the Disney elephant because of the ear-like fins on its head. It is the deepest living octopus species, found down to 7,000 meters. Unlike its shallow water cousins, it doesn't have an ink sac because there is no light to hide in, and ink is useless in pitch blackness. Instead, it relies on energy conservation. The Dumbo octopus swallows its prey whole, unlike other octopuses that tear food apart. It hovers above the ocean floor, flapping its ears to steer. This adaptation allows it to move with minimal effort in the crushing pressure. Its existence is a reminder that the deep sea isn't just a place of horror. It creates forms of life that are whimsical, gentle, and perfectly adapted to a slow-paced life in the shadows. You might think the blue whale is the longest animal, but the deep sea holds a rival, the giant Xenophyophore. It can grow up to 40 meters long, longer than a whale. But here is the twist. It is not a single animal. It is a floating colony of thousands of tiny individual organisms called zooids. Each zooid has a specific job. Some are for eating, some for reproduction, and some for propulsion. They are clones working as one. This living curtain of death drifts through the water, trailing stinging tentacles to snare prey. When illuminated by a submersible's lights, it glows like a bioluminescent city in the void. It challenges our very definition of an individual. In the deep ocean, cooperation is so extreme that separate bodies fuse into a single, functioning superorganism to survive the harsh environment. On the abyssal plains, we find herds of sea pigs. These are not actual pigs, but a type of sea cucumber called scotoplanes. They have tube feet that look like chubby legs, and they march across the seafloor in large groups, vacuuming up organic mud. They are the essential gardeners of the deep, turning over the sediment and keeping the ecosystem healthy. Without them, the ocean floor would suffocate. Their respiratory system is bizarre. They breathe through their anus using a structure called a respiratory tree. When threatened, some sea cucumbers can eject their internal organs to distract a predator, regenerating them later. It is a grotesque but effective survival strategy. The sea pig might look like an alien potato, but it is a biological marvel of efficiency in a food-poor world. Size doesn't always equal power. The cookie-cutter shark is small, only about 50 centimeters, but it is a fearless parasite. It has a unique mouth that suctions onto larger animals, whales, tuna, even nuclear submarines, and twists to carve out a perfect circular chunk of flesh, like a cookie cutter. It doesn't kill its prey. It just takes a snack and leaves a scar. It is the mosquito of the deep ocean. Its underside glows green with bioluminescence, blending in with the faint light from the surface, except for a dark collar that mimics the silhouette of a small fish. This optical illusion lures predators in. When a tuna approaches to eat this small fish, the cookie-cutter shark attacks the attacker. It is a master of deception, turning the hunter into the hunted with a brilliant biological trick. In a world of currents, sometimes it is best to stand still. The tripod fish has evolved long, stiff rays on its fins that allow it to stand on the soft mud of the ocean floor like a camera tripod. It faces into the current, waiting for tiny crustaceans to drift into its mouth. It is nearly blind, relying entirely on touch and vibration sensors in its pectoral fins to detect prey. This stance lifts it above the boundary layer of the current where the water is stagnant, placing it right in the flow of food. It can stand motionless for hours or days, conserving energy. The tripod fish is a lesson in patience and engineering. Instead of chasing food and wasting calories, it has turned its own body into a passive fishing trap, perfectly tuned to the physics of the water. In the mesopelagic zone, hiding is a challenge because of the faint silhouette you cast against the surface light. The hatchetfish has solved this with counter-illumination. It has light-producing organs called photophores along its belly. It adjusts the brightness of these lights to perfectly match the sunlight coming from above. To a predator looking up from below, the hatchetfish becomes invisible. This is the deep-sea version of a Klingon cloaking device. But it has another trick. Its eyes are tubular and point permanently upwards, locking onto the faint shadows of prey above it. The hatchetfish is trapped in an evolutionary arms race involving optics and light. It is a world where being seen means death, so animals have become masters of manipulating photons to survive. The Atala jellyfish is deep red, a color that renders it invisible in the deep blue sea. But when it is attacked, it doesn't hide its screens with light. It produces a dazzling rotating display of blue bioluminescent flashes. This is known as a burglar alarm. The goal is not to scare the attacker, but to attract an even bigger predator to come and eat the attacker. It is a high-stakes gamble. If you try to eat me, I will call something that will eat you. This complex behavior shows that bioluminescence isn't just a flashlight, it is a language. In the silence of the deep, light is the primary mode of communication, used for screaming, flirting, and lying. The Atola jellyfish turns the darkness into a neon battlefield of strategy. Drifting silently, we see the comb jelly, or ctenophore. Unlike jellyfish, they don't sting. The rainbow colors pulsing down their sides are not bioluminescent, but diffracted light from tiny beating hairs called cilia, which they use to swim. They are the largest animals to move using cilia. They are ancient, perhaps one of the very first branches of the animal family tree, independent of jellyfish. Despite their beauty, they are voracious predators. They use sticky cells called colloblasts to capture prey like flypaper. They can expand their stomachs to swallow prey larger than themselves. Some species are invasive and have disrupted entire ecosystems when introduced to new waters. They are fragile, gelatinous ghosts that have survived for over 500 million years, outliving the dinosaurs by eons. As we reach the 40th minute, we must look at the smallest but most numerous residents, viruses and bacteria. A single teaspoon of deep-sea mud can contain over 1 billion viruses. They are the invisible engine of the ocean. By infecting and killing bacteria, they release nutrients back into the water, fueling the entire food web from the bottom up. This viral shunt ensures that carbon and nitrogen are recycled efficiently in the cold dark. Without this microscopic war constantly raging in the sediment, the deep ocean would be a graveyard of locked-up nutrients. These tiny entities control the chemistry of the ocean and, by extension, the planet. We have traveled from giant whales to microscopic viruses, seeing that every scale of life is interconnected in the abyss. To understand the trench, we must understand the machines that take us there. In 1960, the bathyscaphe Trieste made history. It was not a submarine but an underwater balloon, using gasoline for buoyancy because gasoline is lighter than water and cannot be compressed. Suspended beneath it was a heavy steel sphere holding Jacques Piccard and Don Walsh. They descended for nearly 5 hours into the unknown. At 9,000 meters, a loud crack echoed through the sphere. A plexiglass window had fractured under the pressure. In a moment of terrifying decision, they chose to continue. When they finally landed, they stirred up silt that clouded the view, staying for only 20 minutes. That brief visit proved that life existed at the bottom, changing science forever. It was a moon landing moment for the oceans, yet it was largely forgotten by the public. It took 52 years for humans to return. In 2012, filmmaker James Cameron designed the Deep-Sea Challenger. Unlike the clumsy Trieste, this was a vertical torpedo designed to plunge fast. Cameron was the pilot, the engineer, and the film crew all in one. He sat in the sphere so small his knees touched his chest, descending alone into the void. He described the experience as journeying to a desolate, alien planet. During his descent, Cameron lost his thrusters and hydraulic systems began to fail. He was truly alone, 11 kilometers from the nearest human, separated by a wall of water that would crush him instantly if the hull failed. His expedition brought back high-resolution 3D images and new geological data, proving that the drive to explore is as much about storytelling and passion as it is about raw science. The modern era belongs to the limiting factor, piloted by Victor Vescovo. This titanium marvel is the first vehicle certified to dive to the bottom of the ocean repeatedly. Vescovo launched the 5 Deeps expedition, mapping the deepest point of all 5 oceans. He found that the Mariana Trench is not a smooth valley, but a scarred landscape of collapsing walls and microbial mats. One of the most challenging aspects of these dives is the return. It takes hours to ascend. Pilots sit in the dark, listening to the creaking of the hull as the pressure releases. It is a meditative, almost spiritual experience. Vescovo even found a new deepest point, correcting our maps. This ongoing mission is crucial because we cannot protect what we do not know, and we are finally pulling back the curtain on the Hadal Zone. How do these machines survive the pressure? Regular steel submarines would be crushed like soda cans. Deep-sea vehicles use syntactic foam, a special material made of billions of hollow glass microspheres embedded in epoxy resin. This material provides buoyancy and doesn't crack under pressure. The personnel sphere is usually made of titanium, machined to be a perfect sphere within millimeters. Any imperfection in the sphere would result in catastrophic failure. The engineering precision required is higher than that of a spacecraft. In space, the pressure difference is only 1 atmosphere, inside versus vacuum. In the trench, it is over 1,000 atmospheres. The ocean tries to force its way in with relentless power. Every dive is a testament to human engineering to find the fundamental forces of nature. The connection between the deep ocean and space is profound. NASA uses underwater environments to train astronauts for spacewalks. The isolation, the reliance on life support, and the hostility of the environment are nearly identical. In fact, studying extremophiles in the Mariana Trench helps astrobiologists understand what life might look like on Jupiter's moon Europa or Saturn's Enceladus. Both Europa and Enceladus have subsurface oceans beneath thick ice shells. If life can exist in the cold, dark, high-pressure environment of our own trench, fueled by chemical energy, then it is statistically probable that life exists in those alien oceans too. The Mariana Trench is our best laboratory for preparing to search for extraterrestrial life. We are exploring our own basement to learn how to explore the stars. There is also a psychological toll to deep diving. It is called the break-off phenomenon. As pilots descend past the sunlight zone, they often report a feeling of detachment from humanity, a sense of spiritual isolation. The world above ceases to exist. In the absolute silence and darkness, the mind can play tricks. Some pilots describe a profound peace, while others feel an overwhelming sense of insignificance. This effect is similar to the overview effect experienced by astronauts looking back at Earth. In the deep, you realize how fragile our existence is. You are a tiny spark of consciousness in an infinite black void. It forces a perspective shift, that stays with explorers for the rest of their lives. The abyss gazes back, changing the way humans view their place in the universe. The Mariana is not the only deep trench. The Tonga Trench, with its horizon deep, is the second deepest, only slightly shallower. It is known for its incredible steepness and rapid subduction speeds, making it even more seismically active. Here, the Apollo 13 lunar module's radioisotope generator rests, lost after a failed mission, adding a nuclear element to the deep. Then there is the Philippine Trench and the Kuril-Kamchatka Trench. Each of these Hadal zones is an isolated island of evolution. Animals in the Mariana Trench cannot migrate to the Tonga Trench. The shallower water between them acts as an impassable barrier. This means each trench evolves its own unique species, like Darwin's Galapagos Islands, but inverted, isolated by depth rather than water. The deep ocean also serves as a graveyard for Cold War secrets. The wreckage of nuclear submarines like the USS Thresher and USS Scorpion lie miles deep. These sites are monitored to check for radiation leaks. They are solemn reminders of the risks of operating in the deep. When the Thresher imploded, it happened in milliseconds. The crew likely never realized what happened. These wrecks have become artificial reefs, colonized by deep-sea life. They are time capsules of 1960s technology, slowly dissolving into the ocean. The secrecy surrounding their locations kept the deep ocean floor classified for decades. Much of our early knowledge of oceanography came not from curiosity, but from the military's need to hide submarines in the acoustic shadows of the deep. Speaking of acoustics, there is a layer in the ocean called the SOFAR channel, sound fixing and ranging. At a specific depth, sound waves get trapped and can travel for thousands of kilometers without losing energy. Whales use this channel to communicate across entire ocean basins. A blue whale in the Indian Ocean can theoretically hear a whale in the Pacific. Humans have used this channel to listen for Soviet submarines and to authorize nuclear tests. It is a planetary internet of sound. However, our noise pollution shipping lanes, oil exploration airguns is clogging this channel, blinding whales effectively. Imagine living in a world where a constant jet engine noise drowns out your family's voices. The silence of the deep is being destroyed by our industrial ambition. We also physically connect the world through the deep. 99% of international data traffic your emails, this video. Your bank transfers travels through fiber optic cables laying on the ocean floor. These cables are no thicker than a garden hose, yet they carry the weight of the global economy. They drape across trenches and climb underwater mountains vulnerable to sharks, earthquakes, and anchors. Exploring the deep helps us map safe routes for these cables. A landslide in a trench could sever the connection between continents, causing an information blackout. The deep ocean is not just a remote wilderness. It is the physical foundation of our digital age. We rely on the stability of an environment we barely understand to keep our modern society functioning. The deep ocean is not just an explorer's playground. It is a pharmacy for the future. Creatures here have evolved chemical defenses to survive in a world teeming with bacteria and predators. Scientists are extracting compounds from deep-sea sponges and soft corals that show incredible promise in treating cancer, Alzheimer's, and chronic pain. The cure for humanity's worst diseases might be hiding in the sludge 5,000 meters down. For example, a drug derived from a cone snail toxin is already used as a painkiller 1,000 times more potent than morphine, but without the addictive risk. Because these animals have been evolving separately for millions of years, their chemical makeup is unique. We are in a race against time to discover these species and their secrets before mining or climate change wipes them out forever. Deep beneath the trench floor, inside the crust itself, lives what scientists call the deep biosphere. Here, microbes live in rocks, reproducing once every 1,000 years or even slower. They are practically zombie bacteria, existing on geological timescales. Some of them have been alive since the time of the dinosaurs. They challenge our understanding of what it means to be alive versus dead. This biomass is massive. If you weighed all the microbes in the deep earth, they would outweigh all the humans and animals on the surface combined. They are the true masters of this planet. Studying how they survive with almost no energy helps us understand the limits of life. If biology can endure this, then life in the universe might be the rule, not the exception. We no longer need to catch animals to know they are there. A new technology called eDNA, environmental DNA, allows us to scoop up a cup of seawater and sequence the genetic material left behind scales, mucus, waste. From just one sample, we can detect every shark, whale, or squid that has passed through the area recently. It is like CSI for the ocean. This revolutionizes deep-sea exploration. Instead of spending millions on submersibles to spot a rare fish, we can just test the water. It reveals a hidden richness of biodiversity that cameras miss. We are realizing the trench is far more crowded than we thought. The silent deep is actually a bustling metropolis of life, leaving its genetic fingerprints everywhere in the dark water. Currently, we have better maps of Mars than we do of our own ocean floor. But a global initiative called Seabed 2030 aims to change that. They plan to map 100% of the ocean floor by the year 2030 using fleets of autonomous surface vessels and underwater drones. These robots will work 24/7, pinging the depths to reveal mountains, trenches, and canyons we never knew existed. Completing this map is crucial for navigation, tsunami prediction, and understanding climate models. It will essentially drain the ocean digitally, allowing anyone with an internet connection to explore the Mariana Trench on Google Earth with high precision. We are the generation that will finally close the last big gap in the map of our world, turning the terra incognita into familiar territory. The ocean is our shield. It has absorbed over 90% of the excess heat generated by human carbon emissions. The deep ocean acts as a massive thermal battery, storing this heat for centuries. Without the deep ocean's capacity to absorb this energy, surface temperatures would be scorching, and life as we know it would be impossible. The abyss is silently saving us every single day. However, this comes at a cost. The deep ocean is warming, and oxygen levels are dropping, a phenomenon called deoxygenation. This forces deep-sea animals into narrower habitable zones. We are changing the physics of a place we can barely reach. Understanding the trench helps us monitor the health of this planetary air conditioner. We cannot take its resilience for granted. Beyond the science and the fear, there is simply the beauty of the abyss. The deep ocean is the largest gallery of art on Earth. The delicate flash of a comb jelly, the stoic patience of a tripod fish, the terrifying majesty of a shark. These are masterpieces of evolution. They exist whether we see them or not. They have a right to exist, independent of their value to humans. We often fear the dark, but the Mariana Trench teaches us that darkness is not empty. It is a canvas for light. It is a place where life refuses to give up. In a world of noise and chaos on the surface, the deep offers a kind of eternal, quiet wisdom. It reminds us that we are just visitors on a planet that is mostly water and mostly deep. As we near the end of our hour-long journey, ask yourself, why do we explore? Is it for resources? For fame? Or is it because we simply need to know? The Mariana Trench represents the ultimate limit of our planet. Going there is an expression of the human spirit's refusal to accept boundaries. We look into the abyss, and we see a reflection of our own drive to discover. Every time a submersible descends, it carries the hopes of all humanity to understand our home. We are the only species that builds machines to go where we cannot survive, just to see what is there. That curiosity is our greatest trait. The trench is not a place of death. It is a monument to life's tenacity and human ingenuity's reach. Let's look back at where we have been. We started in the sunlit shallows, dived through the Twilight Zone with its faint glimmers, survived the Midnight Zone's monsters, crossed the abyssal plains, and finally touched the bottom of the Hadal Zone. We've seen plastic at the bottom of the world and life thriving in boiling vents. We have traveled 11 kilometers down, effectively journeying through the layers of Earth's soul. This vertical journey covers more distinct ecosystems than a trip from the equator to the North Pole. It is a world of extremes, extreme pressure, extreme cold, extreme darkness. Yet, it is all one connected ocean. The water in your cup today might have been in the Mariana Trench 1,000 years ago. We are all connected to this deep blue cycle. The exploration has only just begun. Less than 20% of the ocean floor has been mapped in detail. There are thousands of trenches, seamounts, and canyons waiting for the next generation of explorers. Perhaps one of you watching this will be the engineer who designs the next deep sea sub, or the biologist who cures a disease with a deep sea sponge. The frontier is not just in space. It is right here, beneath the waves. Keep looking down as well as up. The mysteries of the deep are waiting. As we protect these places, we protect our future. The Mariana Trench will outlast us all, a silent witness to the history of the Earth. Let us ensure it remains a pristine wilderness, a place of wonder rather than a wasteland of our mistakes. Thank you for joining me on this incredible journey to the bottom of the world. If you felt the pressure, saw the beauty, and learned something new, please light up the like button and subscribe to Nightlight Science Stories. Share this video with fellow explorers. Let me know in the comments, would you dare to take a ride in a submersible to the bottom? Until next time, keep your curiosity bright in the dark. Goodbye. End of video. Screen fades to black with ambient underwater sound fading out. Be sure to check out our other videos on space and ancient history. This channel is dedicated to bringing the wonders of the universe to your screen with the most relaxing and cinematic storytelling. See you in the next story.